Hi everybody, in this video we're going to be reviewing a couple transporters. This includes symporters and antiporters. While fundamentally simple, these can get pretty complex in the abstract, and you'll see what I mean in just a second. What's important to keep in mind is both symporters and antiporters are responsible for active transport. So they're pumping things against their concentration gradient. They're pumping things from low concentration to high. And like all active transporters, coupled transporters need energy in order to do active transport. What makes these unique is that the energy that coupled transporters get comes from other molecules flowing with their concentration gradient. So we can talk about symporters and antiporters, and we'll talk about them separately. Let's imagine that we have one molecule, molecule 1, and the concentration of molecule number 1 is very high inside the cell and very low outside the cell. And what we want to do is pump molecule number 1 against its concentration gradient from where it is low to where it is high. That's the active transport. In symporters, that energy is going to come from molecule number 2 following its concentration gradient. Molecule number 2 is very high outside the cell and very low inside the cell. Molecule number 2 wants to flow inside the cell. That's its gradient. So as molecule number 2 flows with its gradient, doing what it wants to do, it generates kinetic energy that is used to carry molecule number 1 against its gradient. The reason why this is called a symporter is because both molecule number 1 and molecule number 2 are moving in the same physical direction. In an antiporter, we'll start with the same scenario. Molecule number 1 is very low in its concentration outside the cell, very high inside the cell, yet we still want to pump it from out to in. We want to move it against its concentration gradient. And just like the symporter, we're going to harness energy from another molecule following its gradient. Molecule number 2 wants to flow from inside to outside and will be allowed to flow following its concentration gradient. But when it flows, that kinetic energy that's released is going to be used to pump molecule number 1. You'll notice the difference, though. Here, molecule number 1 is moving out to in, molecule number 2 is moving in to out. That makes this an antiporter because the physical direction of both molecules is opposite. So how are coupled transporters similar? Coupled transporters are active transporters. They're moving molecules against their gradient, like molecule number 1 is being pumped against its gradient. They do so by allowing other coupled molecules to flow with their gradient, in this case releasing kinetic energy of that flow that is harnessed to pump the first molecule. In symporters, both molecule number 1 and molecule number 2 move in the same physical direction, and in antiporters, molecule number 1 and molecule number 2 move in opposite directions of the cell. And that's it for coupled transporters.